Hello everyone, I'm Miles. Today we'll use a corporate finance example to understand a concept that's often misunderstood, the equivalent annual cost, EAC, in capital expenditure decisions. Why do we have to use equivalent annual cost? Because when equipment has different lifespans and costs are uneven, the total cost becomes meaningless. The only thing that matters is how much you have to pay each year on an equivalent basis. EAC is about compressing a complex, multi-year cash flow decision into a single annual price tag. Let's work through a problem. Step 1. Find the new machine's EAC as our benchmark. It costs $4,800 today with $1,100 in annual operating costs. It lasts 6 years, has a $1,200 salvage value, and a 12% discount rate. First, find the PV of the total cost. That's $4,800 plus $1,100 times the 6-year 12% annuity factor, minus $1,200 divided by 1.12 to the 6th power. The annuity factor for 6 years at 12% is 111, so the PV for the new machine is $8,714. Next, convert it to EAC. EAC-1, the EAC for the new machine, equals $8,714 divided by 4.111, which is $2,120. Remember, this 2120 isn't the total cost forecast, but rather the annual rental equivalent for replacing the old machine. Step 2. Is it worth keeping the old machine for one more year? Note, the old machine's $1,500 value is an opportunity cost, included in the total cost or liquidated for other uses. PV1 is $1,500 plus $1,200 over 1.12 minus $700 over 1.12, totaling $1,946. Since it's 1 year, EAC1 is 1946 times 1.12, equaling 2,180, which exceeds 2,120, so the first year is costlier than a new machine, not worth it. Step 3. Keeping the old machine for 2 years, PV2 is $1,500 plus $1,200 over 1.12 plus $1,300 over 1.12 squared minus $400 over 1.12 squared, totaling $3,289. EAC2 equals $3,289 divided by AF2, 0.12, which is $3,289 divided by 1.69, equaling $1,946, which is less than $2,120. Conclusion, it's cheaper to keep using the old machine for at least 2 years. Once we've decided to use it for 2 years, the cost for the first 2 years becomes sunk costs, and sunk costs are no longer part of the decision-making process. So now the real question is just this: is it worth waiting that extra year for the third year? Step 4. Only look at the incremental cash flow for the third year. The PV at the end of the second year equals $400 plus $1,400 divided by 1.12 minus $200 divided by 1.12, which equals $1,471. The incremental EAC for the third year is $1,471 times 1.12, which equals $1,648, less than $2,120. Conclusion, it's worth it to keep using the old machine for a third year. So the final decision is to use the old machine for the full 3 years and replace it at the end of the third year. The essence of equivalent annual cost, EAC, is not just about calculating annual costs, but also about putting a price on waiting to replace. It doesn't just care about how much you've already spent, but also whether it's still worth waiting another year. When the annual cost of waiting another year exceeds the EAC of the new machine, rationality demands that you replace it immediately.